Jump in. Good morning and welcome to our webinar, Simple Wireless That Delivers. It's a LoRaWAN basics discussion. My name is Heath Jenkins. I'm with the product management team here at Sensicon, and I'll be presenting. We also have Sabrina Pauly from our marketing department helping out with keeping me on track time-wise and gathering questions. Sabrina, can you just unmute and say hi real quick?
Hey, good morning.
All right. Thanks, Sabrina. If you do have a question, and this is an important part, obviously, if you have a question, just drop it in the Q&A section. You should be able to find a button up at the top of your screen for Q&A. Leave that there. Sabrina will get it, and we'll run through as many as we can at the end of the webinar. It's important to note that we are recording. What we're going to do with that recording is we plan on posting it by noon tomorrow, and for all attendees, we'll send an email link, and obviously you could watch it again, share it as widely as you want. We absolutely encourage that. And again, that'll be posted by noon tomorrow. This is the first in a series of webinars about LoRaWAN and gaining a basic understanding of LoRaWAN fundamentals. Our intended audience is individuals interested in implementing LoRaWAN who are looking for practical insights into the technology. And just a word, this is an educational, informational webinar. It's not, we're not trying to sell you anything, but I'd be remiss if I didn't tell you a little bit of background about Sensicon. Sensicon was established in 2005, and we specialize in instrumentation for a wide variety of healthcare, laboratory, HVAC, and general industrial applications. We are instrumentation people. That is our focus. And we are beyond excited to add wireless products to our stable this year. It's a great time to be alive, and it's a great time to be in this technology. So let's go ahead and dive in. Our agenda, what we're going to cover today, what is LoRaWAN? Just a kind of a shallow dive into the background technology. We'll talk about the benefits and limitations of LoRaWAN, common applications. I like to cover that. Not only for folks that are in those applications, but for folks that might have an idea generated based on that discussion. I think that's my favorite part of any presentation is real world application. And then we'll talk about getting started. How does someone attending this webinar go from here to having a fully installed, functional, beautiful LoRaWAN network of their own? We'll talk about that, and it's easier than you might think. And then we'll summarize and do a Q&A. And like I mentioned before, it should take 30 minutes for the presentation itself, and I've allotted about 10 minutes for the Q&A. So make sure you ask any questions. No stupid questions. So what is LoRaWAN? LoRaWAN, the word itself stands for Long Range Wide Area Network. Well, that's open to interpretation. What is long range? In this case, long range can be multiple miles. Competing technologies can be in the 30 feet range for Bluetooth, for example. Wi-Fi could go several hundred feet. There's competing long range technologies that go several thousand feet, but this is miles. Many manufacturers you see will have 10 kilometers or 10 miles on their website. And while that is achievable, there are some caveats, and we'll put a pin in that and talk a little bit more about that in a later slide. But just keep in mind that this is pretty long range relative to other industrial, commercial communication protocols. And then wide area network, that's a term that's been around for a while. It's a network that extends over a large geographic area and connects multiple smaller networks. So nothing new there. What makes this possible? And I promise I'm not going to drown anyone in technical jargon, but I do need to emphasize how important this part is early on here in the presentation. Chirp Spread Spectrum, CSS, I'll use the abbreviation as much as possible, was originally developed for military applications. In fact, LoRaWAN is one of the few non-military applications using it, and it's the key to LoRaWAN's superpower. In essence, and I'll break this down word by word here, chirp spread spectrum, the chirp part of that denotes a signal that increases or decreases in frequency over time. It'd be comparable to the change in the pitch of a siren, a police car, and an ambulance, or something like that. And then spread spectrum just indicates that that signal is spread over a wide frequency range. So the beauty of this, and what you get with those two elements combined, is a great resistance to interference, highly sensitive receivers, and low transmission power consumption and scalability. And I don't want to just blow by those. One of the things I'd like to add is security, which is inherent in using CSS. This is very hard to hack. It's very hard to eavesdrop, even before you introduce any encryption, which it also has. So this is the fundamental difference between LoRaWAN and other wireless technologies. So what does a LoRaWAN installation look like? It looks like this. Basically 4 major components. On the far left, you see the sensors, also called end nodes, end devices, field devices, whatever you want to call them. They're the part of the system that captures the data and transmits versus LoRa modulation. They transmit to a gateway. The gateway has 2 functions: to translate LoRa signals to high-speed IP data, regular internet protocol data, and send that data to the cloud. And there's one note about gateways. This will be the only time during the presentation I'll mention this, but I think it is important to mention private networks versus public networks. Sensicon and many other manufacturers and end-to-end solution providers are focused on private networks, but there is a decent part of this industry that is on public networks, where you do not need a gateway. You are transmitting directly to a public network gateway. These are predominant in cities where gateway density can allot that. You can actually install citywide and potentially not buy a single gateway. But for purposes of our conversation today, we're going to focus on private networks, because anyone can use a private network and buy their own gateway. So that's the gateway side of this network map. From the gateway, it goes to a network server, and the network server has several functions. It keeps track of all the LoRaWAN devices. You can't just have any LoRaWAN device hop onto your network server and be served up to your application. It needs to know what to expect. It needs to track that and accept and reject as appropriate. It also routes packets to the application server, and sounds pretty easy, but with multiple billions of different destinations globally, this knows exactly where to send your data. And then it manages security keys. So this does have end-to-end encryption. Both sides of this route, this travel, are encrypted and decrypted. So very, very safe way to communicate. So, and didn't want to forget the application. The application is where data can be viewed and devices managed. Basically, any laptop, mobile device, any computer that you can access anywhere in the world, anytime, can be served up your data through that cloud-based network server. So more on that later. In the meantime, I'm not going to drown you again, I promise, in technical jargon, but this is the OSI model, which is a conceptual framework for networking. And I only really want to hit on that layer 1 and layer 2 and 3, because that's what makes LoRaWAN different than everything else. Layer 1 is where LoRa modulation takes place. It's where that chirp spread spectrum takes place. You can see over to the right, I have Simtech 2013. That's the company and the year that this was released. And so it's been out for about 10 years, a little over 10 years. And so it's got a little experience under its belt and success. Moving up the chain to the MAC layer, that is layers 2 and 3. That is actually, you'll see the name over to the right, LoRa Alliance 2015. That's a nonprofit similar to the Wi-Fi Alliance, the Bluetooth Special Interest Group, Zigbee Alliance. They're formed, and in this case, LoRa is formed to develop and promote LoRaWAN by standardizing interoperability. the devices can play nice together instead of having proprietary frame structures and specialized equipment and company-specific protocol. It'd be like the Wild West. So they make it so this works for users, works for manufacturers, and the market can grow. Layers 3 through 7, not a lot of difference. That has to do with transport and getting to the end location, but those layers are going to be very similar to anything else you'd see as far as internet traffic. So there are some differences between countries that it's important to hit on here. You saw in that lower block of the OSI model, if you were looking carefully, you see US 915, EU 868. This denotes the fact that lower modulation is taking place at different frequencies based on your region of the world. Those are set by, in the US, the FCC, and in Europe, an organization called ETSI. And that 915, that 866, you can see there's a note about it being the ISM band. It's an unlicensed spectrum for industrial, scientific, and medical applications. And that there are power restrictions there, so everybody's not stepping on everybody else because it is unlicensed. There's also some duty cycle restrictions, but for LoRaWAN, it's a perfect fit. It's a match made in heaven. That ISM band works fantastically. So now that we know a little bit about LoRaWAN, let's see, and what's under the hood there, let's see how this benefits the user. You can see the chart there to the right denotes where LoRa operates in a bandwidth versus range matrix. You can see that as far as range goes, it covers everything that Wi-Fi can. It goes down into the lower ranges and all the way even beyond cellular as far as the distance that this can transmit. Bandwidth is where you're going to see us, LoRa, come in a little bit lower than Wi-Fi and cellular. Actually, it's a lot of bit lower, and we'll talk about that in a second. But this is not, I emphasize this point, it's not a high bandwidth application or technology, I should say. So you do have the long range. You have deep indoor penetration. The reason you have deep indoor penetration is because this is in the megahertz spectrum instead of the gigahertz spectrum. And those longer wavelengths can bend and pass through obstacles like walls much more easily. So that's good for, also good for the fact that it has a high link budget. And what I mean by a high link budget is you can lose a lot of the signal, a lot of the power of the signal as you get further away from the transmitter, and still capture and recover that signal reliably. So that deep indoor penetration is helped by both of those facts. Robust interference resistance, that ties in with the indoor penetration. Low power consumption, I haven't mentioned what that means. Low power consumption doesn't mean 120 volts or 24 volts. It means 3, 4, 5 volts, typically powered by batteries that are readily available commercially, lithium, alkaline, those sorts of things. So this is not running on a ton of power, and it doesn't need to. And we'll circle back to that in a second as well. It's cost effective. Most sensors are less than $400. I'd say 95% of the sensors that I've seen on the market are less than $400. And in fact, there are several out there for less than $100. So this is an inexpensive way to install a communication system, a wireless system, and simple to boot. We'll talk about simplicity in a second. It's scalable. One gateway can handle thousands of sensors. And I'll repeat that because it's important. One gateway can handle thousands of sensors. So if I'm sitting on the other side of this webinar, I'd ask, well, what's a gateway cost? It sounds like this would be an expensive proposition. Gateways, inexpensive as well. $200, $300, $400 is not unusual for a gateway, and it can handle thousands and thousands of sensors. It just kind of boggles the mind what those little things can do and the value that they pack. And then the strong security features that I mentioned inherent in LoRaWAN and augmented by AES 128 bank level security. So a lot of good things there as far as the benefits of LoRaWAN. Let's dive in a little bit more on that range, that distance, because this is one of the bigger advantages, and it can also be something that takes a little bit of understanding before you dive into an installation. Many manufacturers will quote 10 kilometers or 10 miles as their usable range. That number is absolutely achievable, but it is reliant on a favorable installation. And when I say a favorable installation, I'm talking mainly about three different things. The height of the gateway, the higher the gateway is installed, the fewer obstacles you're going to have to pass through, walls, trees, those sorts of things in order to get to the device. So while it'll work great at eye level, at regular floor level, if you were looking to extend the range, getting this thing, the gateway specifically 20, 30 feet into the air, 20, 30 meters into the air, would definitely boost the distance that you're getting. The type of environment that you're in, that's absolutely critical. Are you in a rural country type area? Are you suburban? Are you urban? And while this is a very good technology for obstructions like you'd see in an urban environment, it's not immune to the impact of those obstructions. So distance will depend on that. And then finally, the antenna size and type. That's something that can have a really good impact on distance. So you can see in the bottom left, that world record's 517 miles. They floated a balloon with a gateway several thousand feet into the sky, and it was a beautiful day, and everything, all the stars aligned and set the world record for a LoRaWAN transmission at 517 miles. If the stars don't align, I wouldn't expect that. So if the stars aren't aligning like that, more typical is sort of that satellite photo you're seeing in the right, where maybe you're in a multi-campus environment, maybe you have a subsidiary down the road, maybe you have a field that you're trying to measure various sensors and get the information there. Typically less than 3 miles would be something that I know we'd feel a little bit more comfortable stating and setting expectations along those lines. So that's the transmission distance advantage. The low power advantage actually comes partially from CSS and partially from what we're going to talk about here. On this chart that you can see right now, you can see the current draw in common battery-powered applications. So, for example, a flashlight will draw 750 milliamps as you use it. LoRaWAN, I'm going to skip over the next one to the right and go straight to what we're talking about here. A LoRaWAN sensor, when it's active, is drawing maybe 130 milliamps. Okay, that's a reasonable number. But if now you go back to that remote control, a remote control draws 150 milliamps. And if you think about that, a remote control's working maybe, 15 feet, 20 feet in your house? And we're asking a LoRaWAN transmitter to transmit several miles. So you get a lot of bang for your buck. That's lifting a lot of weight, that 130 milliamps, and it's a beautiful thing. Now, this is an important element. Going to the far right to that second arrow there, the sleep time of a LoRaWAN sensor comes into play. And here's, when I say come into play, it sleeps a lot. A typical LoRaWAN installation will have over 99% sleep time. So what this means is it's going dormant. It wakes up on a set interval, typically on a set interval, although it can be triggered, but typically on a set interval, 10 minutes, 15 minutes, along those lines, and sends a transmission. That transmission only lasts 50 milliseconds, and then it goes back to sleep. So the combination of these two items, that CSS, the fact that you're sending a signal at a lower power level than you need to in order to get it as far as you want to, along with the fact that it's sleeping a lot of the times, means that you're going to have batteries. Not uncommon at all to see 10 years quoted as the battery lifetime from some of our competitors. 5 to 10 years, that's a sweet spot for a lot of LoRaWAN sensor manufacturers. So that's a long lifetime. It does depend on the interval and other factors, even the temperature, those sorts of things that impact batteries. So let's see what it does during that awake time. During that awake time, it's sending data. That's number 4 in that network. You can see there in the red box. And it's storing that data. You can trend that data. Just popped up a graph there of a month worth of temperature readings. You can slice and dice that data both within a platform. And this is agnostic. We have our own platform, but you can use basically any platform that is compatible with LoRa. You can trend that data. You can export that data to do even more things with it. You can set up user-defined email and text alerts. So let's say that you don't want a room to get over 85 degrees Fahrenheit or below 50 degrees Fahrenheit. You can set triggers for both of those sides and email and or text to multiple people. That's a really, really useful application for the platform. And then device management, it's limited, but interval changes, for example, you want to tell the sensor to wake up every 10 minutes instead of every 15 minutes. That can be done from the platform as well. So we've gone through the power, the distance, the data advantages of LoRaWAN. And those are some really great things to talk about, but there's no such thing as a free lunch, I think the saying goes. And there are some limitations, and we need to touch on those here briefly. The low data rate is probably one of the bigger disadvantages. This is going to transmit from 0.3 to 50 kilobits per second. To give you an idea how that stacks up against what you're receiving at home while you're streaming, you probably are aware that 100 to 200 megabits per second is not unusual at home, consumer grade. So we're talking about 1/2 of a percent of the data rate that you achieve at home. So as long as you know that, you can function very well. It's a disadvantage, but it's not crippling for what we're trying to accomplish in most applications. Limited bandwidth, that goes hand in hand with low data rate. Here's another one that's going to stand out, is high latency. Latency is the time it takes to get from when a signal is sent to when it's received. And again, going back to the consumer application, you're looking at 50 to 100 milliseconds being typical for a home. Here we're talking about with LoRaWAN 1 to 10 seconds. So a factor of 20 to 200. If you need something quick, LoRa is probably not going to be a great fit for you. And then limited downlink. Downlink means sending from the platform to the device. Limited there, again, not a big deal. We're not trying to stream movies on the device or anything. And then the reliance on gateways. You need a gateway if you're doing this private. And that's not a super inhibiting factor, but it's not a cell phone that you can pick up and start communicating right away. You do need that gateway. So you can see the applications that wouldn't be a good fit. They include VoIP, real-time navigation, really anything where you need to respond quickly and or control quickly. So what do these limitations mean in the real world? Here's a Venn diagram. If you have a low duty cycle, if you have low power, so you're not monitoring, or I'm sorry, you're monitoring but not controlling, you're remote and you have no local power, for example, that is a sweet spot for LoRaWAN. That's ideal. That's perfect. If you had either one of those but not the other, it's also something that can be highly considered, especially the monitoring but not controlling aspect. So that's where the real world is going to be able to use LoRaWAN quite successfully. And many applications fall under that. This is a list of 36 different types of measurements that you can take. It's a fairly exhaustive list. No manufacturer makes all these. In fact, Sensicon makes the first 6 on that list: pressure, temperature, humidity, contact, analog current, analog voltage. I see in the marketplace, it seems like every couple weeks, some new measurement type being released. And Sensicon is going to be no exception to that. We're actively looking to expand our stable of LoRaWAN products and hold tight for more releases to do that and serve our customers better. So there are a lot of different measurement types. What specific applications and markets are good? I grew up on a farm. The things that they can do in agriculture now are just amazing. For LoRaWAN, temperature and humidity, an example may be installing temperature and humidity LoRaWAN sensors in a barn to ensure that the cattle, the pigs, chickens, whatever, are not being stressed by heat and humidity. The soil moisture and pH can be used in fields to change the amount of fertilizer being applied. And the list goes on and on in agriculture. It's a really good fit. HVAC, another one firmly in the wheelhouse for LoRaWAN. You can use it in offices to maintain comfort. You can stage your filter changeouts for your HVAC system based on the actual differential pressure rather than just changing them out on a schedule. A service company could make good use of that. You can monitor energy consumption, occupancy. There are a ton of applications within HVAC for LoRaWAN. Smart cities actually get a lot of the press, and that's no surprise. There's a lot of good use cases in cities, in urban areas, owing to there's a lot more measurement point requirements in a city. There's the resistance to interference that we talked about. There's the gateways and even the more likely availability of public gateways. And city planners just love data. So we've seen bids go out and jobs awarded for 10, 20, 30,000 sensors in a smart city. Some of that, if not all that, or if not most of that, is utilities. For example, reading gas meters. Instead of having to drive by or actually physically look at a meter, you can now just get this information back at the home office miles and miles away for tens of thousands of meters. And then finally, pharma. Pharma is an exciting one for us. Pharma has some strict requirements on recording and record retention that plays well with LoRaWAN and the platform and the ability to store the data. If you want to ensure that the entire production process, transportation process, storage is under a certain temperature and humidity, for example, that's a perfect fit. If you need anything else in that environment to just help monitor or make sure that you don't exceed limits, LoRaWAN's a great fit. So we've got all these great fits. How does one get started in LoRaWAN? Small installations, I'll preface this by saying small installations are exceedingly simple, very close to plug and play in many instances. And when I say small, I'm talking about maybe a couple dozen sensors and a couple gateways. You do not need a staff of IT people. You may not even need a single IT person. We've seen folks set them up in less than 15 minutes from start to finish. So stressing that point, I will say that larger ones, where you're talking about hundreds or thousands of sensors, you'd probably want to do some surveying. Gateway placement might be important. And gateway overlap, by the way, just as an aside, gateway overlap isn't a bad thing. You can have some redundancy there in the event that something happens to one gateway. You've got some backup. So to get started, you need to define your requirements. Are your sensors and gateways going to be indoor or outdoor? Are you going to operate on a public or private network? Once you know that, selection of the hardware, including the sensors, the gateway, the platform, steps 1, 2, and 4 on our little network map, selecting a manufacturer for those. And just a note there, some companies, and Sensicon's one of them, provide all three. So we are an end-to-end solution provider. Some just specialize in 1 or 2 of those. So just be aware of that. And then plan your installation. For a smaller one, a couple sensors, probably don't need to plan a lot. But as you get larger, the benefit of thinking through and mapping out where you're going to have your sensors and gateways, that makes a lot of sense. And then after that dotted line, post-purchase, the installation and testing of the gateway and sensors typically just goes in the order of powering up the gateway. And some companies, not all, Sensicon again is one of them, will pre-provision the gateway, which makes this very, very close to plug and play, because we're telling it what sensors you purchased, and to accept the transmissions from those sensors, we're telling it where to route, what network server, what application server. We're giving it all of the inside scoop, the security keys, in order for you to just plug it in and go. And then you can just confirm connection via the platform. Also locally at the gateway, it'll tell you, but you can also confirm it on the platform. Sensors, again, pre-provisioned and ready to go. Just place the batteries in and verify the data is flowing on the platform. 15 minutes or less for a small application is something that's very doable. And then finally, configure the platform for your needs. And what I'm talking about there is naming your sensors to something that's meaningful to you. If you're an admin, meaningful for your end users. Adjust your intervals as needed. How often do you want to receive a transmission? And then alerts, the very, very powerful feature that lets you know when your measurements are going outside the bounds of what's considered normal. So we know a little bit about the background and the benefits and everything. Let's take just a moment to summarize here. We're getting towards the end. Due to that unique application of chirp spread spectrum, that's a tough one to say. Long distance and low power are enabled without detriment to reliability. So those top two owe themselves to CSS. You've got versatility. We saw the 36 different measurement types. There's a lot you can do with LoRaWAN, and there's more coming every day. Application fit, that's just a note that you want to make sure that you're monitoring and not necessarily controlling in a continuous fashion or in real time your application. If you pass that hurdle, there's a good chance that LoRaWAN could work for you. Ease of use, I just touched on that. Ease of installation, ease of use, those are great things. Data acquisition, just data, giving you insight that you didn't have before and allowing you to know more about your measurements in your application than you've ever known before. And then finally, a strong outlook. And I put this in, I had to think about it a little bit, but if I'm sitting on the other side of this webinar, why is a strong outlook for LoRaWAN matter to me? And I will say that it should matter because this is a newer technology. It's been out for 10 years, but the projections for the next 10 years are for compound annual growth rate of 35% per year. And what that means to someone who's thinking of buying today is that support, that ecosystem of products and new products and potentially expanding your use is going to be there, not just today and tomorrow, but well into the future. And they only go out to 2033 right now as far as the projections, but it looks very good. With that being said, I will, if there is a fit for any of you, I would humbly request that you consider Sensicon as your full service provider here. And let's move into Q&A. I'll turn it over to Sabrina. And Sabrina, did we get any questions that we can help out with?
Hey, thank you so much for that, Heath. Yeah, it looks like I have just a few. For starters, can you provide any specific applications where LoRaWAN may not be an ideal solution?
Yeah, it really does go back to if you have a need for safety related or control related activity, that's probably not going to be a good fit for LoRaWAN. And it's kind of nice. If you can clear that challenge, that hurdle, then there's room for conversation once you clear that. So it's pretty straightforward. One other one that I didn't mention earlier is high mobility application. You can do asset tracking with LoRaWAN, but large distances, large geographic areas are not going to be updating in a fashion that's going to probably be workable. That handoff, that handshake from one gateway to another is just not a strength of LoRaWAN. So high mobility, anything that requires real-time control, those are ones where you're definitely not going to be ideal. What else you got?
It looks like I got one more. What would you say is the biggest challenge you see with installations?
The biggest challenge we see is firewalls, and those are typically for larger customers, corporate customers. The smaller companies that have some flexibility with how their firewalls are managed are a little bit more straightforward. But when you get into a larger, I'm talking Fortune 500 company, they have very strict rules on how their firewalls are accessed and pass through, what kind of traffic can pass through. So that's the biggest hurdle that we've seen with installations. Typically, the distance we can talk through with a customer, the distance, and ensure that we're both on the same page there and expectations are set correctly there. So I would definitely say that firewall is the bigger of the challenges that we've seen. But if you're a smaller midsize, less of a issue, less of a challenge. Anything else, Sabrina?
Looks like that's all the questions that we have for right now.
Okay. All right. Thank you. Well, I'd like to thank you all for joining today. I hope that you found this worth your time. And for those interested, we will be having another webinar in early December. It's cutting the cable, building your wireless LoRaWAN network in 4 simple steps. We'll go into more detail about what it takes to go from decision that you want to get into a LoRaWAN network to finally having that stream of data informing your life. So in the meantime, we invite your inquiries at any time. You can see our contact information there on the left and look forward to talking to you in the future. LoRaWAN's not a fit for everyone, but if it is a fit for you, we'd love to talk. Thanks and have a great day.